Right, hello. I will be with you in just a moment. I'll let everybody else join. Right, anyone got any questions based on what they've been doing this past week? Maths is the main focus of what we'll be doing. I have in front of me whatever year 9, year 10, and 11 were given. Although some of the year 11s may have got a slightly different homework on the angles and polygons. If you did, then tell me, and I will have to find that. See if we've got any questions. Got some questions. Got some questions. Question 15, classic. Is that for the year 9 one? Yeah, yeah, fine. So just so you know, there were 3 different topics here, which are still relevant for everybody. We have got some stuff on surds and indices, which will be useful to look at. We have got some straight line graphs and simultaneous equations, as well as some functions and graph transformations, which is the more complicated one, which the year 11s were doing. Let's see if I can just fix this. Right, only got one question at the moment, so I will go to that first, and we can see as we come along. Right, 15 on here. 15, oh yeah, horrible. Okay, let's have a look at this, shall we? So, we have a question here, which is, I'll just move this out of the way. Asking you to simplify this. Now, ordinarily, this would be on a non-calculator paper, just to warn you. Even though with a calculator, in theory, if you type this in, you would actually get straight to the answer. But we're obviously not going to do that. We're going to do it without one. So we have got the square root of 80 being added to the square root of, and that is a slightly bit of a misprint, but it's the square root of all of that. 2 and 2 over 9. Okay, let's deal with this first. Right, when you simplify surds like this, especially when there's a big number in the middle, nobody has said that they can't hear me. Can everybody hear me? Someone say yes. Someone say yes if you can hear me. Okay, yeah, unfortunately. Um, I can be heard. All right, yeah, I've got enough yeses. Don't, that's it. Right, thanks. Right, so square root of 80, we would split into, microphone closer, um, the into two numbers that multiply to give 80. Now, you want one of those to be a square number. The best option is the square root of 16 and the square root of 5. You have a little bit of a clue in the question in that they've got something root 5 here. But I'm going to split the square root of 80 into 16 times 5 because that does make 80. And the square root of 16 can become 4, which means that that has simplified to 4 root 5. Okay, the next thing to do now. So I'll leave that as it is. We need to move on to this. Now, in most maths questions, when you have a mixed number, which is a big number and a fraction stuck to it, most of the time you should convert that into an improper fraction. The way you do that in this case is you do 2 times 9, which is 18, plus the 2 to get 20, and it becomes 20 over 9. So what this really is the square root of 20 over 9. Okay. When you have a square root of a fraction, you basically square root the top and you square root the bottom separately. So it's just square rooting the top and square rooting the bottom. Now, the easy bit here is the square root of 9, which is 3. So I've turned the square root of 9 into 3. Just to be clear, nobody has to raise their hands. There is a chat thing, a Q&A thing, in which you can just type in anything that you would like to ask. Only I will see it. Just so you know. The square root of 20 is the other thing to simplify now. Now, the square root of 20, put it up here. So you've got to do loads of different bits in this question, is the square root of 4 times the square root of 5, which is 2 root 5, because that root 4 turned into 2. So now what I've got is 2 root 5 over 3. So what has this question really become? It has become 4 root 5, which is what the root 80 was, plus the square root of 2 and 2 ninths, which I've just worked out as being 2 root 5 over 3. And so we're more or less there. Wait, have I done something wrong? Let me just check that I've done anything wrong here. 80 is 20, root 20 over root 9 is... Yeah. Okay, that's a little bit awkward, that one. But to finish this off, it's not the easiest thing to finish off, but we've got 4 root 5 plus 2/3 root 5. 4 plus 2/3 is 4 and 2/3, which is 14 over 3. That's how many root 5s we've got here. So this is actually 14 root 5 over 3, which is what the final answer is to that question. I think there was another way to do that, which I seem to have forgotten, but that is the correct answer. Was there another way to do this? No, but that is the answer to the question. So I remember that's the answer to the question. But to get there, I thought there was an easier way to get there. But the hard bit really is from there to there, what you actually do. So that is the answer to that question, but make sure you show you're working out as I have done. Awesome. Right, then the only other thing that somebody has asked me is that in the year 10 booklet, there was a question from 10 to 15. If there are no other questions on that, by the way, I will just recap some of the topics that were done and maybe go through some of the questions as well, but I like to do specific questions if you ask me. So, question 10 to 15, most of them, that sounds like, from this booklet. Okay, here we go. So, this is a question that, by the looks of it, you can't tell what topic it is necessarily, but it is a simultaneous equation question. Because it says the sum of two numbers is 15. The sum of two numbers means you add them together. So if we take, because we've got to work out what these numbers are, right? Let's pretend the numbers are x and y. So the sum of those two numbers, in other words, x added to y, is 15. And then the difference of the same two numbers is 8, which means that if you take one away from the other, you get 8. So x take away y is 8. And then you just need to do a simultaneous equation here. What I would do, which I feel like most people should do, is subtract this way. Because your x's are already the same. Remember, when you got taught this, you should have been told that you should try to make your x's the same or the y's the same. Now, the x's are already the same. There's 1 and 1 here, and they're both positive. So if I subtract, I would get x take away x, which is nothing. Be careful with this. That is 1y take away minus 1y. Okay, so 1 take away minus 1 is 1 add 1, like that. It becomes an add, which makes you've got 2y. And 15 take away 8 is, by my reckoning, 7, which means that y is 7 divided by 2, which I'll write as a decimal for now, just because it's easier to work out, 3.5. Okay, and then what you need to do is go back and find what x is. If we go back to this equation here, x add y was 15. So if y was 3.5, then x must be 15 take away 3.5, which is what, 11.5, I think. Yeah. 11.5. So when you add them together, you get 15. If you take them away, you get 8. So it all works. Just see if anybody has any other questions. Yeah, there's some other year nines. Let's go from straightforward to the rest question. Yes, the question about the homework school question. If possible, send it on the WhatsApp, and then I will get to it. If you could take a picture of it and send it on the WhatsApp, I will figure it out. Hopefully, I can't guarantee it. But I'll carry on. So you've said 10 to 15, right? So I'm going to keep going. Right. 11. Right. 6 cups of tea and 4 cakes cost £13.20. 5 cups of tea and 4 cakes cost £12. Is £10 enough to buy 3 cups of tea and 4 cakes? The way to do this is, even though it doesn't explicitly say it in the question, is you want to work out how much this is all going to cost. And therefore you need to work out how much 1 cup of tea is, so you can times it by 3, and how much 1 cake is, so you can times it by 4, and then you can figure out what it all adds up to. So if I'm going to say this, that x, just to use x and y because you're familiar with them, x is the cost of 1t, and y will be the cost of 1k. Right, let's now read this. 6 cups of tea. If I've got 6 cups of tea, then the cost of it is 6x. If I've got 4 cakes, then the cost of 4 cakes is 4y. And the total cost, they've said, is £13.20. 5 cups of tea and 4 cakes cost £12. So 5x plus 4y is 12. So that's what you want to get to in this question. You want to write these equations out exactly as I've done. You can use different letters, sure, but you can use T and C if you like. But I'll just use X and Y. Then I will take away this way. The reason I'm going to take away already is because my Y's are already the same. I don't need to do anything. I know you could try and times this equation by 5 and this by 6 and stuff like that, but there's no point because the whole purpose of what you're doing in simultaneous equations is to get rid of one of the letters by making them the same, and they're already the same. So what you can just do is take away. In fact, there was a much easier way to do this. It's really obvious that 1 cup of tea costs £1.20, but I'll leave that. So x is, so 6x take away 5x is 1x. The y's disappear. 13.20 take away 12 is £1.20. And that is what x is, which is what 1 t costs. Okay. Let's now use that to find what a cake costs. Well, 5 cups of tea and 4 cakes cost £12. So 5 cups of tea would be 5 times this £1.20, which is £6. No, £7.20. I'll just check that. So 5 cups of tea. If we just go back to this equation, 5x, so 5 times £1.20 is 6, plus 4y is 12. If I now take away 6, then 12 take away 6 is 6. If I divide by 4, 6 over 4 is basically £1.50, isn't it? It's 1.5. Yeah, 1.5. Right. So now I know what the cost is of everything. So now I'm going to get 3 cups of tea, which is 3 times £1.20, which is £3.60. And 4 cakes. One cake is £1.50, so 4 of them are £6. That costs £9.60 altogether. That means that yes, £10 is enough to buy 3 cups of tea and 4 cakes. Make sure you answer those questions. Let me see if anybody asked anything. Um, yeah, I'll go back to the year 9 booklet one thing. I'm just doing these in order, really. Question 4, yeah, I'll get through every question, don't worry. I'm just doing it in order. Um, what people have asked me. Right, question 12. Solve the simultaneous equations. Um, right, this one's a little bit harder because you have to do something compared to the previous questions we've just done. What I would always do is I would try to make my x's the same, and I would do that in this case by multiplying this equation by 2. That would make that 4x plus 6y equals 20. And this equation is 4x minus y equals minus 1. So I didn't change the second equation because it was already a 4. So happy with that. I will now subtract. The 4x take away 4x is nothing. Be very careful when you're subtracting negatives. 6y take away minus 1y adds the y, so you get 7y. And again, 20 minus minus 1 is 21. You add the 1. And now you can see that y is 3 because you divide by 3. And now I would go back to this and say 4x minus y is 3, equals minus 1, which means that 4x is, if you add that over, minus 1 add 3 is 2. And then divide by 4. 2 divided by 4 is a half. And that's your answers. They are your answers to that question. Okay, right. Right, I can keep going. You've asked me loads, haven't you? Question 13. Solve the simultaneous. I might just do. Oh, well, let me see. If they're all the same, I'm not doing every single one. You should be able to figure it out yourself. Right. I'll do one more. You can try and do the next two. Solve the simultaneous equations. Again, what I would do is I would make the x's the same. There is another way to do it. You can times this by 3 and then do something, but I'm just going to do what I think works every time, which is make these numbers the same. So I can do that by timesing this equation by 3, that will turn that to a 6, and timesing this equation by 2, that will also turn that to a 6. So what do we have? 6x plus 9y equals 53 times 3 is 159, I think, my calculations. And then this equation I'm going to times by 2, and I will get 6x minus 2y equals 38. 19 times 2 is 38. Right, now that I've made the x's the same, I can minus. So 6x take away 6x is nothing. 9y take away minus 2y, again, be careful, is 11y. And 159 take away 38 is 121. And if you know your times tables, you know that y is 11, because 11 times 11 is 121. And now that you know that y is 11, let's go back to this equation and write down that y is 11. Add 11 to both sides, and you will get 30 over here. And divide by 3, and you will get 10. That is the answer. I won't do the next two, because you should be able to do them based on what I've just done here. Right, let me go back to the beginning. Oh, God. Okay. Let me just answer any of the questions from the Surds and Indices booklet that are left. 10B in the year 9 booklet. So let me just go back to that, and then I'll move on to anything else. 9. 10B. Sorry, I got confused. 10B. Right, this one. Okay, work out the value of everything you see here. Anything to the power 0. Hopefully you were explained. For anything at all to the power 0, the answer is 1. So that's already a 1. Plus, this is now a little bit complicated, I admit. Okay, let me explain how to do 8 to the power minus 2/3. Okay, so a negative power, what it does is it flips over whatever you've got here. So 8 flipped over becomes 1 over 8. Okay, because it is ultimately a fraction. So you can flip it over to 1 over 8. That flips it over. It is still to the power 2/3. When you do to the power 2/3 to a fraction, you do it to the top and to the bottom. When you do it to the top, nothing will happen because 1 to the power anything just stays as 1. But 8 to the power 2/3, let me explain how you do that. Let me do that over here. 8 to the power 2/3. You look at the number at the bottom first, and that tells you to cube root the 8 that you've got. And then the 2 at the top will end up being squaring the answer. The cube root of 8 is 2, because 2 times 2 times 2 is 8. And then you square the 2 to get 4. So that becomes 1 over 4 after all of that. So first thing we did was flipped over the 8 to 1 over 8. Then we did the top and the bottom of the fraction to the power 2/3. 1 to the power 2/3 didn't do anything. And 8 to the power 2/3 is 4. So we end up with 1 over 4 now. And it's just 1 plus 1 over 4, which is 1 and a quarter or 1.25. That is the value of what we see here. Bum, 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 bum. 1 to 4 from the year to 1 to 4. We'll see. If I feel that let me see, that 1 to 4 from the year 10 booklet. If these are simultaneous equations, then I absolutely am not doing them. But if they're straight lines, then I'll come back to them in a moment. What's okay, sort of. Okay, yeah, I can do them. But let me see what else there was first. So you said 4 and 5. Question 9. Yeah, 9. Question 13. I think we did that one. Sorry, trying to manage all of this. Question 13. No, I didn't. Right, let me do that. Work out the value of 8 to the power minus 2. Once again, as I just said, the minus, what that does is it flips over the big number that you have there. That's all it does. It doesn't make it minus or anything like that. It just flips it over. Then, if you're squaring a fraction, you square the top, which doesn't do anything to a 1, and you square the bottom. 8 squared is 64, and therefore the answer is 1 over 64. Bum, 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 bum. 4, 6, 13, and 17 in the year 9 booklet. 13 I'm doing now. This one's difficult, I accept. Particularly difficult. So how do we do this? Well, actually, it's not that bad. I just told, oh, I don't know whether that's a power or not. Must be. Right, I think there's a typing mistake in this question. I think that should be 8 to the power 2/3. It can't be 8 and 2/3. So if it's 8 and to the power 2/3, I just told you what that was. Remember, that is the cube root of 8 to the power 2. The cube root of 8 is 2, and 2 squared is 4. So what we actually have here is 4 to the power x equaling 4. So it's basically saying what value goes there so that the answer is 4. Well, it's just 1 because a number to the power 1 just doesn't change. So that has to be the answer. Assuming that is a power, it must be. It is a power. So that is a difficult indice question. And this one, I can't see what it says. Right. 3 to the power 0 is 1, because anything to the power 0 is 1, times 3 to the power 1 plus 3 squared. I think that's a plus. Yeah. So 3 to the power 1 is 3, and 3 squared is 9. So that's 12 in there. That's therefore the square root of 12. Just 1 times 12 is 12. And then what you have to do is you have to simplify this third by changing it to the square root of 4 times the square root of 3, because that's what that can be. And the square root of 4 becomes a whole number, 2. And you stick the root 3 onto it, and therefore that is your answer for that slightly complicated third question. So we got 4, 6. Let me check if I did 4 and 6 earlier. 4, yeah, again, this should be easy enough now that we've just done what we've been doing. But a negative power flips over what you've got there. That's all it does. The other number stays there. So the minus has no effect other than to flip over what you've got. And then squaring a fraction just means square the top and square the bottom. So times the top by itself, 49, times the bottom by itself, 25. They want the answer as a mixed number. So you have to go, well, how many 25s go into 49? The answer is 1. What's the remainder? The remainder is 24 over 25. That is the answer as a mixed number. That's question 4 on that one. And then 6. Yeah, 6 is a bit horrible. Right. For number 6, what I'm going to do is I'm going to focus on the numerator of the fraction, which says 5 minus root 3, brackets 3 minus root 3. And we are going to expand the brackets. So the way you expand these brackets, change color, is do 5 times 3, which is 15. 5 times minus root 3, which is minus 5 root 3. Minus root 3 times 3 is minus 3 root 3. Remember, when you multiply a number by a surd, the thing with the square root, you just stick them together, you leave the number on the outside. But then when you do this times this, firstly, it's two minuses, so they make a plus. And the square root of 3 times the square root of 3 is the square root of 9, but that just simplifies back to 3, doesn't it? So I'm going to put the 3 there. So what do I have here? I've got 15 plus 3, which is 18. Minus 5 minus 3 is minus 8 root 3. And if we go back to the denominator now, they had a 2 on the bottom. So the 2 on the bottom is just dividing everything by 2. So I do 18 divided by 2 to make 9. And this 8 divided by 2 to make 4. The surd doesn't change. You only apply that to the outside of it. And so you end up with the answer. That's quite a difficult question, to be fair. 4, 6, 13, and 17. 13 I've done. And now we just do the last one, hopefully 17. Okay, so this requires you to simplify these as far as possible. And also the clue is in the question because they want it as something root 5. When you simplify it, one of them should be a root 5. If you do that with this 80, then the other one has to be 16 because 16 times 5 is 80. The square root of 16 is 4, and you stick the root 5 onto it. And then you do the same with this. So if I say one of them's got to be a 5, then what number times is by 5 to give 180? I think it's 36. So that 36 conveniently becomes a 6, and then the root 5 is stuck onto it. Now we've got 4 lots of root 5 plus 6 lots of root 5, which is 10 lots of root 5. Right, that, I'm just making sure there is anything else. 13, 14. I think I've done those. 13 I've done. I shouldn't have to do 14, really. But when you have a surd squared, then it means you times it by itself. If you times that by itself, what does it end up becoming? Well, it becomes the square root of 9, which is 3. So when you square a surd, you end up with whatever's inside it. So that will become 5, that will become 6, that will become 7. And then just answer the question. Should be it. 13 to 14, I think I've done. Right, that means I can you leave this? Sorry, I missed the questions here. Can you leave the symbol negative? The answer was yes, you can. If that's the answer, that is the answer. To the question I did before. I don't know which question I did before now. Was it the third? Yes, sorry, yes, that I knew that was it. So you're asking me, because it says leave your answer in that form, can you leave that as a minus? And the answer is yes, you can. Basically, what we're saying here is that A equals 9 and B equals minus 4. So if B is minus 4, it still works. Do you see what I mean? Because the plus and the minus make a minus. So yes, don't get too stressed out about the sign that they ask for in the question. The answer is what it is. Don't let that throw you. Don't think that you've done it wrong just because that sign is not the same as what they've got in here. Because signs can change, right? Depending on what's after them. If I've got a plus, but it's followed by a minus, then it's become a minus. If I've got a minus and it's followed by another minus, then it becomes a plus. So signs are not really that big a deal when it comes to these questions. Right, someone anonymous has said question 14, as if I'm meant to understand anything from that, so I'll ignore that. Right, I think I can move on to the 10 stuff. Right, I'm moving on. Right, 10 to 15, I've already done, right? Sort of. I'm not doing all of them, but I've done 10 to 13. They just, once you get the hang of some of the simultaneous equations, you should be fine. Um, the homework question that has been sent on WhatsApp, I'll do afterwards. Question 4 and 5. I'll do first. Right. Um, so this question said that we've got a point A, right? I want to do a little sketch for this, right? Because I've got time, so why not? Um, So it says A is the point 2 minus 5. Don't be afraid to do a very little sketch if you feel it helps you. Okay. 2 negative 5 is roughly over here. Okay. So if that was 2 and that was minus 5, then that would be roughly where the point A is. The point B is 4, oh God, 4 minus 9. Right. Okay. Wait, let me fix this. Um, right. I'll just have Okay, B is 4 minus 9. Backfire this is. 4 is there, minus 9 is obviously way down here somewhere. Okay, right, very good. There's the point B. Right. The question is to show that the gradient passing through this is minus 2. If I wanted to work out the gradient of a line, if you have it drawn, you can draw a little, turn it into a little right angle triangle like that. Okay. And then just count how many that way you've gone. And because you've got the numbers above here, you know that you've gone across 2. And then do the same with how many down you've gone. If I've gone down from minus 5 to minus 9, I've gone down 4. And again, just write those two numbers down. And then the gradient is this number divided by this number. So minus 4 divided by 2 is minus 2. And that is the gradient. And you have shown that the gradient between A and B is minus 2. That's how you do the gradient. Now, I personally, for those of you who want to just know how I would do this, I would have just looked at these X and Y coordinates, and I would have said, how do we get from here to here? From minus 5 to minus 9, I take away 4, right? If you know your negative, be careful your negative numbers. How do you get from 2 to 4? Do the same here. I add 2, right? And then the gradient is this divided by this. Make sure you do the Y change divided by the X change. So minus 4 divided by 2 is minus 2, and you have done it. That's how I would have done that. Anybody got any questions? Um, just to be clear, whoever is the anonymous attendee asking me questions, I am not responding to you unless I can see a name. Thanks. Right. The other questions, what were they in the year 10 booklet? Um, one, 3 on the year 10 booklet, someone has said. 3. Right. Ugh. Let me make this bigger. Right, so I did 4. I need to do 5 as well, but I'll do 3. And I'll do 5. Okay. So question 3 says, on this grid, A is the point 0, 1. Is there. Um, M is the midpoint of AB, which is 2, 7. Gradient of AB is 3. Oof, quite a hard question. Work out the equation of the line through C that is parallel to AB. Okay, this is how I'm going to do it. I'm going to do this reasonably quickly. Because M is the midpoint, okay, then, well, firstly, actually, let's do it a different way. We're trying to find the equation of this line, right? This is the question. The equation of a straight line is always y equals mx plus c. So we need to find the gradient. We need to find the y-intercept. Now, the gradient of this, we already know because we're told that this line is parallel to this line. Parallel means the gradient is the same. And so they've told you in the question that the gradient of AB is 3. That means the gradient of this line is 3 as well. So y equals 3x plus something. The only thing we're left to do now is find out what this c is. Now, there's no obvious immediate way to find out what that is, but because we know that this is in line with this, right? If I can figure out what this coordinate is, then the y coordinate here will be exactly the same because they're in line with each other. And then whatever that number is will just be the answer. So how can we find out what this point B is? They've told you that this point is the middle of A and B. It is the midpoint. So this is how I would do this. Again, it's just there's different ways to do these kind of things. I would make a little triangle here and say, okay, how did I get from A to M? I went from a coordinate of 0 to a coordinate of 2, so I went across 2, right? On the x direction. And on the y direction, I went from a coordinate of 1 to a coordinate of 7, so I went up 6. So if M is halfway, then surely to get to B, I would do all of that same thing again. I would go across 2 and up 6 again. So across 2 from where I'm already at, which is 2, I would be at 4 here now, wouldn't I? That must be 4. And then up 6 from where I was already. I was already at a y coordinate of 7. If I go up 6, then this y coordinate must be 13. And therefore, the answer to the question is y equals 3x plus 13. That is how I would have done that. So a midpoint, you know that you're sort of going the same amount across and up each time. And then you can sort of figuring it out from there. Is this paper higher off? This is the homework, just to be clear. So this is the homework that we gave to the students in year 10. In terms of topics, simultaneous equations and straight line graphs are all in both foundation and higher level in answer to that specific question. But you might not have got this specific homework if you got a homework at all, because I know you're online. So yes, the questions are relevant to both foundation and higher because it's just the topics are straight lines and simultaneous equations. So all of it is. Right, what was next? Question 5, I think somebody asked me. Oh, I didn't even finish this one, did I? Okay, I need to do this question, don't I? Yeah. Right. Okay. So question 4, which I worked out the gradient of this line through A and B, if you remember. It also said that asked you, is this point on the line passing through A and B? Now, the only way to do this is to find the equation of the line through A and B. Now, I already know it has a gradient of -2. Already, I know. Because we did that in part A. I want to find out what this is, because once I found out what that is, I can then check whether this point is works in the formula. So to do that, I'm going to use one of these 2 points that I had earlier. That like point A was 2, -5. So I'm going to use that. So when y is -5, x is 2. -2 times 2 is -4. And then the c, if I add 4 to this, is -1, which means my equation is y equals -2x minus 1. I appreciate I may have done that quite quickly, but the equation of that line, which you need to get to be able to do this question, is that. And now the question is, does this point lie on the line? Well, to do that, I want to take the x coordinate and put it in and see if I get 601 as my y coordinate. So if x is -301, -301 times -2 is 602. And then the -1 means that y is 601. So that works. See that when I subbed in -301, I got 601. So therefore, yes, it does, because that's the situation. Okay. So I've done 4 and 5, done 3, 1 to 4 on the attempt. So I've done 4. Right, I'll just do the first 3 questions as well, just reasonably quickly. On this grid, draw the graph of y equals x plus 1. That's a good question to do from x is 0 to 5. When you have to draw a graph and it gives you the equation, the best thing to do, if it hasn't already done this for you, is to make a little table like this. And it says values of x from 0 to 5. So I'll just put these in 0, 1, 2, 3, 4, and 5. Okay. And then all you do is you follow what this says to get the y coordinates. Y is x, add 1. So you take the x and you add 1 to it, take the x and add 1 to it, and keep going. And what these are now is a load of coordinates that you can plot. So 0, 1 is about there. 1, 2 is there. Yeah, you get the gist of it. And then you just draw a line through those and you have done the question. And once you have done that, when it says use the graphs to solve the simultaneous equations, for those of you who I taught over the weekend, I will have mentioned that simultaneous equations, what you're doing when you're doing simultaneous equations is you're actually finding where two lines cross each other. You don't realize it when you're doing it because you don't see a graph, but that is what you're doing. So if I had drawn this with a thinner line, it would have been easier. But let's pretend that I did, and let's pretend that's where they cross, in which case the answer to the question would be 2, 3. X is 2 and Y is 3. That is the coordinates at which those two lines cross each other. That's question one. Question number two says draw the equation of line A. I'm not actually answering that question because I'm just not. On the grid, draw the line y equals x. The line y equals x. I shouldn't do this question. I've decided. I've decided I'm not doing this question because there is no reason why it should not be able to be done. Question number three, I've done. Question number four, I've done. In fact, it's a little bit unfair, isn't it? I'll do part of it. Y equals x. The line y equals x is a diagonal line that just goes through there. Beyond that, you should be able to do the rest of it. Oh, 14. Someone just said question 14. Meaningless. Question 6 on the year 10 booklet has been asked. However, I don't know who asked it, therefore I'm not answering it. Yeah, no. No, question 3 on the year 10 booklet. Done that, haven't I? Yeah, okay. Right, that means the only immediate thing to do is a question that has been sent to me, which I will write out first, which is on the topic of straight lines and stuff, just so you know, which was a straight line has equation, I won't write the whole thing out, y equals a half x plus 1. Just so you're aware, there is a WhatsApp telephone number, and if you don't have it, then ask someone. And you, in these sessions, if I have time, I can always try and help with them if necessary. So y equals a half. I can't guarantee it. Well, do our best. Right. Then it says there is a point P on the straight line. Point P has y coordinate of 5. And the question says find the x coordinate of P. Well, again, for those of you who I explained this to at the time, I told you that the equation of a straight line, I think of it as like a machine into which you can put x values and find out y values, or you could put in y values and find out x values. So when this tells you that P has a y coordinate of 5, and the question says, what is the x coordinate? What I do with that 5 is I put it into the machine where the y is and change it to a 5. So I get 5 equals a half x plus 1. And then I work out what x is. I take away 1. 5 take away 1 is 4. A half of x is 4, so x must be double everything, which is 8. And that is the answer to that question. X must be 8. Then it says, write down the equation of a different straight line. Sorry, I'm just abbreviating things. That is parallel to y equals a half x plus 1. Parallel, right? As I said earlier, the word parallel means that the gradient is the same. So if two lines are parallel, they have the same gradient. Now, where's the gradient of this line? It is there. So if I need the equation of a different line, then the one thing I have to make sure is that the gradient stays the same. And then all I need to change is this number to anything. There are infinite answers to this question. Just change it to anything else, like +2 or plus a million, whatever you like, as long as it's not +1, because that would be the same straight line. We need a different straight line. In terms of what this would look like on a graph, y equals a half x plus 1 would look, if that's 1, it would sort of look like that. and y equals a half x plus 2 would sort of look like that. You see what I mean? They're parallel, but they have different y-intercepts. So one is a little bit above the other. And that's all that would be. And then the next question on this was rearrange. And if you remember, you do have to do a lot of rearranging when it comes to these equation questions. But in this case, it says rearrange y equals a half x plus 1 to make x the subject. Okay, making x the subject means get the x by itself on one side of the equals sign. Oh, let me ask a question. Right, to rearrange this, I would move this 1 to this side. So it would be y minus 1 equals a half x. For those whoever's asked about the telephone number of the WhatsApp, if you were here and had a lesson this weekend, then you would have received a homework booklet. On the back of that homework booklet, there will be a telephone number with a green WhatsApp logo next to it, which will answer your question. And to make x the subject, what I would do, because that's a half x, I would now times by 2. So I would be have an x there. And if I times by 2 on the other side, then you could use brackets if you want, or you could do 2y minus 2. It doesn't really matter. But that has rearranged this to make x the subject. It depends what you want to do. Right, and that answers all of those questions. Is there anybody here from who had issues with any of the year 11 homework? Because nobody has actually asked any of that. So therefore, I'm assuming that nobody has any major issues with it. Okay, what should we do next then? I may just then, since it was asked, have a look at some of the other simultaneous equations questions at the bottom of this booklet. Yes, so just to confirm for everybody, there is a WhatsApp number now on the back of every booklet. You should find it, and that will be it. Let's just do this question. Solve the simultaneous equations. Show you're working, don't use trial and improvement. Okay, as I say, the one method that always works with these questions is to look at your x's and make them the same. So I've already got 5x minus 4y equals 24. If I times this equation by 5, I will have 5x plus 10y equals 9 times 5, which is 45. So make your x's the same and then subtract. I am going to, just to show you a different way of doing it, subtract this way. Okay, so I'm going to do 5x, take away 5x that way, which is 0. 10 take away minus 4 is 14 because you end up adding the 4. And 45 take away 24 is 21. This is horrible. Okay, that's pretty horrible. That. Right, anyway, so y is 21 over 14, which is 3 over 2, or 1.5. Okay, fine, 3 over 2, 1.5. Okay, now that we know that that is that, let's find out what x is. I'm going to go back to this equation. Maybe use a different pen. I know that y is 1.5, right? And 10 times 1.5 is 15. So I've got 5x plus 15 equals 45. If I now take away 15, I get 45 take away 15, which is 30. And 30 divided by 5 is 6, which means that my answer is that x equals 6 and y equals 1.5 or 3 over 2. Write it however you wish. That would be that one. And then let's do the last one now that I'm here. And if you could, while I'm doing this question, if you want to think about any other maths topic or area of concern that you have, then I can find some questions on it after I do this. Anything you like. Solve the simultaneous equations. So again, I'm going to make the x's the same. So I'm going to times that equation by 3 so that I get 6x over here, and times this equation by 2 so that I get 6x over here. Top equation by 3 and you get 6x plus 12y equals 3. Bottom equation by 2, so I get 6x minus 10y equals 14. And then I will subtract again. Subtract this way, subtract this way. Make sure you subtract in the same direction, okay? Because obviously that changes it if you don't do that. 12 minus 10 is the same as 12 add 10, which is 22. And 3 take away 14 is minus 11, which means that y is minus 11 divided by 22, which is minus a half, because 11 is half of 22. So now that I know that y is minus a half, I may go back. I'll go back to the top one here because the y is positive. It's a little bit better. If I go back to 6x plus 12y equals 3, now that I know that y is minus a half, 12 times minus a half is minus 6, because half of it, but then change it to a minus. If I add 6 to 3, I get 9, and x is 9 over 6, which is 3 over 2, or 1.5. So don't be afraid of fractions when it comes to these questions. They often end up being fractions. Okay, right. Cumulative frequency and iteration and functions has been mentioned. Okay, yeah, and then let's see what else we got. Trigonometry. Okay, or proof of circle theory. Okay, right, quite a lot there. We go for it. I'm in no rush. Let's go. Right, so I've received. Oh God, there's more. What more? Enlargement. Yes. Okay. Enlargement in year 10 doesn't mean anything. You know that, don't you? But I can do enlargement here. Okay, let me figure out what order I want to do that in. I will start with what I would consider easiest to hardest in terms of the 1, 2, 3, 4, 5, 6 or so things that have just been asked. I'll do one example of each thing, okay? Maybe a couple of each thing. I want to start with enlargement. And I will need to just get a question on it. So I will do that. Bear with me. Um, Right. Stick with that. I suppose enlargement in theory, I was a bit unfair when I said that, but it does get a little bit harder because you can get enlargements with negative scale factors, which is a little bit more complicated, but we will not deal with that for now. I will just do an enlargement question. Oh, God, what any of these? One that actually involves doing an enlargement. That'll do. Right. Two questions I want to do on this, and then I'll move on to trigonometry, a couple of examples. We will do proof of circle theorems and a bit of functions. Okay. The question says to enlarge the shaded triangle by a scale factor of 2, center 1, 0. Okay, when you get a question like this, firstly, find the center, which is at 1, 0. Make sure you don't go to the wrong place. 1, 0 is there, not there. That would be 0, 1. 1, 0. Okay, this is the way I do this. And again, not everybody does this, but I think I would recommend it. Because when you end up doing enlargements with negative scale factors, that'll mean when they say something like minus 2 over here, when you get there, if you've learned it this way, it makes it easier to do that. Okay, so this is how I would do it. From here, I have got 3 points on this triangle. I would count from the center how many across and how many up or down I have to go to get to each corner. So to get to this corner, I've got to go 1 to the right and 2 up. And I'm going to write this down. 1 right, 2 up, like that. Okay, that took me from there to there, right? And then do the same for a different corner. I want to go from the center, 1, 2, 3, 4 right and 2 up. Okay, I'm going to write that down here. 4 right and 2 up. Gets me to another corner. And then do the same to this corner. 1 right and 4 up, isn't it? 1 right, 4 up. And write that down. Okay, what we need to do now is look at the scale factor. And all the scale factor tells you is to times by 2, which means that I just take all of my directions and these things that I've just done so far and double everything. So 1 right becomes 2 right. 2 up becomes 4 up. Just double the numbers. That's what you need to do. Okay, so I've doubled all the numbers. And then all you do now is follow these directions from the center. So always go back to the center and follow that. So two right and four up. Two right and four up gets me to here. That's one of my points. Eight right and four up gets me to there. No, it doesn't. No, it doesn't. Hang on, I've got that completely wrong. Two right and four up. One, two, three, four is there. Okay. Eight to the right and four up. That eight to the right and four up is one, two, three, four is there. Um, two to the right and eight up. One, two, three, four, five, six, seven, eight is there. Just be careful of that. And then you've got your three new points, and you have enlarged your shape by a scale factor of two from that center point. Um, and that's it. That's how you do that kind of question. The only other type of question on this topic you get is when you get given two shapes and you have to explain or describe the transformation that takes you from one to the other, as is the case with these two, for example. So let me just show you that. So, as I say, two types of questions. Either you have to draw the new shape, as I just did, following the instructions, or you get given two shapes and you have to describe how you get from one to the other using the transformations. Now, obviously, this is taken from an enlargement thing, therefore it is an enlargement. But you remember there are four transformations. You could enlarge, there's reflection, there's rotation, and there's translation. If the shape has got bigger or smaller, it is always an enlargement. So that's fairly obvious in this case, right? So to answer this question, I would first get a mark for just saying it is an enlargement. Okay. From shape A onto shape B. The next thing I want to say is the scale factor. The easiest way to do the scale factor is just count. So this bottom or top side is 1, 2, 3 long. This side here is 1, 2, 3, 4, 5, 6, 7, 8, 9 long. So that was 3, that was 9, which means the scale factor has to be 3 because it's tripled in size. So your scale factor of 3. And lastly, you need a ruler for this. And I'll see if I can be bothered. But you would need to find the other thing you need to say is the center of enlargement, just like we had the center of enlargement in the previous question that we just did. To do this, see if I can get a ruler. There we go. Right. You'd have to do this reasonably accurately, which is go to the two corners that are the same on each shape, somewhat like so. Oh no, it's really hard to do this. I'm not on a computer. And then draw a line through them. Okay. And then do the same thing with a different pair of corners that are the same, such as those two. Right. Again, I don't think I've done this very accurately. And then you don't need to do it with more, but if you do it with more, you should end up with everything going through a point that is broadly the same. Okay, if we do it with those two, then we kind of end up in the same place, right? So that is the center of a line. You need to say what these coordinates are. I hope it would preferably have gone through somewhere. So it looks like 4.5 and 5 as the center, but they will all go through to wherever the center is. So you just need to do it with two of them, and then you're done. But that is enlargement. There isn't really much else to say about enlargement, which takes us on to the ruler. Out of the remaining topics that people have asked me, I will talk trig, then cumulative frequency. Just so you all know, for the statistics, cumulative frequency, histogram, and all these things, we have a lesson scheduled in, I want to say, in the next month. Yeah, it's either February or March, I can't remember. But we have a statistics-ish lesson that does all the cumulative frequency and histogram and all that jazz. Um, Trig. Right, I'm going to do two examples of trigonometry. Maybe three. Okay. A question involving trigonometry will look something like this. Let's make sure I've got this ready. Yeah. Something like that. And it'll ask you to work out x. In a trigonometry question, what you need to do is label your sides. There are three labels. There is the hypotenuse, um, there is the opposite, and then there is the adjacent. The hypotenuse is the side that is across from the right angle in the question. There will always be a right angle, otherwise it's not a trigonometry question. So H. The opposite is the side that's opposite the other angle given in the question. There will always be another angle, otherwise it's not a trigonometry question. And so that would be the O. And then the one that, if you do it in that order, there'll be one left. And the one that's left is the A. The next thing you do, once you have correctly labeled your sides, is use the magical SOHCAHTOA. And what that tells you, what you have to do is determine which of these three little things you're going to use in the question. And the way you decide that is you decide which side do you know? We already know that that is 7. And which other side do you want to know? This side here, where the X is, which means that we're only going to use the one that has the O and the H in it, which is here. And that little thing, and this is the important bit to remember because this doesn't tell you this, is a little equation that says sine, which is a button on the calculator. After that button on the calculator, you always put an angle. So sine, in this case, is going to be 32, equals, and then in this order, again, very important, in this order, O divided by H. Okay, so that order, O on the top, H on the bottom. That's what this little SOH thing tells you. An equivalent of that is cos angle is A divided by H. Again, the order this is written in is deliberate. What do we do now with this information? We replace the bit after the sine with the angle in the question, which is 32. We replace the O with the O from the question, which is X, as far as we're concerned. And we replace the H with a 7. What do you do from here? Well, to work out X, you need to multiply the 7 to the other side, and you will get 7 multiplied by sine 32. And this is why it's very important to do all of what I have just done before you worry about the calculator. Okay, this is something that let's stress to everybody, that whether it's maths or it's physics, don't pick up the calculator straight away to do stuff. Make sure that anything you're typing into your calculator is already written down on the page. Because now that I've written all my working out, everything's done. Now I'll go to the calculator and type in what it says here. Oops. And as you can see, you can make a mistake when you use your calculator. But if you've written everything down, at least you get your marks up till then. And the answer is 3.7 or 3.71 or whatever for that question. That is how long that side is. Let me do 2 more, and then I will move on. Okay, similar sort of question. What we're going to do first, we're going to label the 3 sides. Somebody asked something. Exact trig values. I mean, I'll come to that in a second. I'm not sure there's much to do about them other than tell you that you have to learn them, but okay. Yeah, I'll do them in a second. Right, so the question, label the 3 sides. We have got a hypotenuse, which is H, which is opposite the opposite the right angle. We've got an O, which is opposite the angle given. Just remember, the O could have been down here if the angle I'd given you was up here. So it's important, the O can change places. So that's O in this case, and that's the A. So in this question, what do we care about? We know that that is 8, so that's the A, and we want to find out what that is. So using SOHCAHTOA, we know we want to use the one with an A and a H. Let's get to the point, which is the C, A, and the H there. So that tells you that cos angle 22 equals, in this order, A divided by H. This time, A is 8 and H is X. So it's so important to get that order right because it changes your next step. As you noticed in this question that I made up, my X ended up on the top, and so I multiplied the 7 by that. In this question that I have made up, my X ends up on the bottom here, not where it was before. So it's in a different place, which changes my next step. What you need to do next to work out what the X is not this times this, which is what we did when it was on the bottom, but because this number's on the top now, you do 8 divided by cos 22. So the position of that number affects your next stage, which is why it's so important to get it right. So 8 divided by cos 22 is the answer to the question, 8.6. Okay, and just on since we're on the theme of exact trig values. As I say, there's not really much to do when it comes to exact trig values, other than tell you that you've got to learn them. There's not really much else to say. So I just get this box here. It is there. So for any non-calculator paper that you will have to do, you may get asked anything about this table, which is the values of sine 0, sine 30, sine 45, sine 60, and sine 90, which I can prove are correct, because if I do sine 60 on the calculator, it will tell me that it is root 3 over 2. So that's what this is. Okay, so it's just these certain values that turn into something relatively nice for sine, cos, and tan. Okay, like whole numbers or a fraction or a bit of a surd. Um, you just have to learn them. And as I say, the reason it can come up on a non-calculator paper is because you could very easily get asked the following question on a non-calculator paper. Um, that. Okay, non-calculator. Let me just show you how to do it. Um, this is the hypotenuse. This is the opposite. This is the adjacent. Which two sides do we care about? We want this one, and we know this one. So it's the one with cos. Ka. That tells you that cos 60 equals um, adjacent over hypotenuse x over 12. And then you times the 12 that's on the bottom. So 12 times cos 60. Ordinarily, at this point, you would pick up a calculator, wouldn't you, and type that in. However, it's a non-calculator paper. But once you are prepared, you will have learnt that cos 60 is a half. And so really the question is 12 times a half, which is 6. And that's how you can do that without a calculator, um, using exact trig values. So you just need you have to just learn them. There's nothing else I can say. And I mean, realistically, it only matters for a non-calculator paper. Remember, if it's a calculator paper, this is meaningless because you type it in and you get the answers. So before any non-calculator paper that you do, whether it's the real GCSE, whether it's a test that you're doing or whatever, just spend a while learning these. I will just give you a little tip, which is that firstly, most of the time, and again, I say most of the time, you will be asked about these three values. Okay? Because firstly, if it was a trigonometry question, we can't have an angle of 0 and we can't have another angle of 90 because then it's not a triangle. So you're only going to get asked really about these three. But that doesn't mean neglect the others, but really, realistically, it's going to be one of those three: 30, 45, and 60. Second thing I can tell you is that if you look at this row left to right, it is the same as this right to left. Okay. So if you've learned the top one, you're going to know the second one anyway. And then it's just doing a little bit more for these, which, so it's easy. It's not that bad. Just spend a bit of time learning it. Right. That'll do a trig. Cumulative frequency. I shall do an example of a question. Where will I find it in here? There. Okay, that seems pretty perfect for me. Okay, the frequency table shows the time taken for 100 people to travel to an event. So we've got 9 people that took between 20 and 30 minutes, 16 people that took between 30 and 40, 20 people from so right. It wants you to draw a cumulative frequency graph for this information. Now, firstly, the clue, if you didn't already know this, is that the graph has got on the x-axis time and on the y-axis something called cumulative frequency. So At the moment, we don't know what cumulative frequency is because we don't have those numbers in the table. We do have the numbers for time, but we have frequency, not cumulative frequency. So when you do any cumulative frequency question and you don't already have that column that says cumulative frequency, you need to make your own column for cumulative frequency. I keep saying that word. Um, and all you then do is you add up as you go along. So this number that goes here is everybody in this section, which is 9 people. The next one is these 16 plus the 9 from before. So that's 25. The next one is these 20 plus everybody before it, which is 45. Then it's these 29 plus everybody before it, which is 74. And then it's these 15 are added on, basically adding on the next number as you go along. So that's what 84 add 5 is 89. And then the number at the end should always be the same as the number of people in total from the question, if it mentioned it. And then what you do is this is the important bit, because this is where graphs get confusing in maths. What you are plotting is this value with the upper values of your group. So when it says 20 to 30 minutes, we use the highest value, the top end of the group. And as you know, in other topics, you use things like midpoints and stuff. So this is where it gets confusing and where you can make mistakes. So in cumulative frequency, we are plotting the highest values because essentially what we're saying here is everybody under 30 minutes was 9 people. Everybody under 40 minutes includes these 16, but also these 9. Everybody under 50 minutes and so on. So it's everybody under those values. So we are plotting, I'll do this reasonably accurately, I think. The value 30 with 9. So 30 and 9 is about here. Again, I'm going to do this reasonably roughly. 40 with 16 is about, it's going up in twos, isn't it? 50 with 45. Sorry, it's quite tedious to watch this kind of thing. I think that's there. 60 with 74. Just be really careful when you're plotting these to be somewhat accurate. 70 with 89. About there. And then 80 with 100 is definitely there. And most of the time, and then you join these up with a curve, most of the time you will find that a cumulative frequency graph forms approximately like an elongated S shape. Let me do that again because I already lost it there. Like an elongated S shape, as you can see there. Most of the time, that's what happens with cumulative frequency. Right, and then, so that's most of the marks in this question, but usually there are 2 follow-up questions. In this case, there's only 1. The follow-up question to this, in fact, there's 3 different things that we can get out of this, right? We can get asked for the median. That's the most common thing to get asked. To find the median, what do you know about the median? It's the middle number. And if there's 100 people, which there are, what's the middle of 100? It is 50. So what you do is you go to 50, which is there on this graph, read across until you hit your line, and read down, and this value is the median, which I guess is 52 in this case. That is the median. The other things that you can get asked about this is something called the interquartile range. So the median is the middle number. The interquartile range is something called the upper quartile minus the lower quartile. Now, the median is in the middle. The upper quartile is 3/4 of the way through. So if there's 70 people, sorry, if there's 100 people, then the 3/4 of the way through would be wherever the 75th person is. So you'd read across from about 75 and down, and that, I'm doing this very quickly now, but that would be your upper quartile. The lower quartile is 1/4 of the way. So lower quartile is a quarter, median's the middle, upper quartile 3/4. So a quarter of 100 is 25. So we're about here. Again, you read across and down. That would be your lower quartile. You can work out those 2 values. Upper quartile minus lower quartile is what's called the interquartile range. The other thing that you can get from this is one of these box plots, which looks effectively, if you've done it exactly as I've done above, your box plot will look a little bit like this. Like that, with the median in the middle there. So a box plot is where you have your lowest value and your highest value, which is in line with there, as you can see, and there. You'll have your median in the middle of the box, which is there. You have your upper quartile at the end of the box and lower quartile at the beginning of the box, which is why these topics can be linked together because you've kind of done all the work to be able to draw it by that point. Okay, what next? Two more things I will do. I will, I mean, a proof of circle theorem is quite a big thing, but I'll do one of them just to give you an idea, a flavor of what kind of thing you're meant to have. And then iteration I won't do, but I think iteration and functions basically means the same thing, by the way. Iteration, by the way, just so you know, is usually just means that you substitute a number into an equation, and then the answer you substitute back in, and then the answer you substitute back in. So as a simple example, if I said to you 2x plus 3 is my iteration, right? And I said start with x equals 1, then what you would do is you would sub x equals 1 into there and get 2 times 1 is 2 plus 3 is 5. With that 5, you would sub it back into there. 2 times 5 is 10 plus 3 is 13. With 13, you would sub it back into there. 2 times 13 is 26 plus 3 is 29. That's what iteration is. It is just taking your answer and repeating it. There's a reason for it, but that is what it is. Okay, that's that. Functions, again, I will just do one, the main thing involving functions, the main thing, and again, you I'll point you in the direction of something you can watch regarding to functions. But the main thing about functions is that if I gave you this function and I said to you, and also I'm not going to explain what it is because it's a bit of a longer process, but a typical question you get is something like this. What is f2? All that means is you take the number 2 and you put it into where the x is in your function. So 2, let's do 3 just to avoid confusion. Okay, so you take the number 3 and you put it into there. No, that's confusing again. Take the number 4 and put it into there. So that would be 2 times 4 plus the 3. Do you see what I mean? I've just subbed the 4 into where the x is. 8 plus 3 is 11. And that is all that is in terms of the basics of functions. But what you often get with functions is asking you another thing, which is the inverse function. And they will put a little -1 there to show they're asking about the inverse. The inverse of a function basically means doing everything that's happened to the x, but in reverse. So for example, if that was a function, and I said, what's the inverse function? Well, the inverse function is x minus 3, because we've added 3 in the original, and the inverse is just taking it away. It's a bit more complicated when there's more things going on, but you can sort of get the gist of it. The way to do it is to write down y equals whatever function you've got and rearrange it to make x the subject. So I'm going to take away 3 and then divide by 2. And basically what we have here is the inverse function, except we don't have y's. The y was there to help us just rearrange it. So the actual inverse function is x minus 3 over 2, which is the exact opposite of what was happening here. What was happening to the x here? I was timesing by 2, then adding 3. In reverse, that means take away 3 and divide by 2. That's what I've got here. So an inverse function is just in reverse. Okay. If you have any specific functions questions, then just send them over to us and I won't see what I can do. Otherwise, there is on the online maths thing, there will definitely be a video on functions. There must be. I just remember doing it, so there must be, which should help. And lastly, I'm going to do one proof of circle theorems, just one, okay? Because it's a complicated topic, but it is very advanced in terms of GCSE maths, so I wouldn't worry about it too much. So first I'm going to do is draw a circle and remind you we do have a specific lesson on the circle theorems, I think, coming up again. I remember that's our schedule coming up soon, for those of you in year 10 at least. The first circle theorem you usually learn is this one, which is that if you have an arc of a circle, AB, and you draw an angle to the middle of the circle from those 2 points, and then draw another angle to the edge of the circle like that from the same 2 points, then the angle you make here is half the angle you make in the middle. That's what the circle theorem is. Okay. Now, obviously, if it was a question said, "Oh, that's 20, what's this?" Then obviously it's 40, right? That's easy enough. However, the topic that you have asked me just now, which is the proof of circle theorems, asks you to prove that that is the case. It asks you to say, okay, well, here you go. Prove that this angle here is twice as big as this angle here. Prove it. Okay. Which is a bit of a more complicated process. Okay, so let's just show you what you have to do so you get the idea, understand that it's complicated, and then you can practice it. So that's not, it is not terrible. It just looks it when I go through it now. So for me to prove that this angle here is half as big as this angle here, or this is twice as big as that, whatever. What I'm going to do first is I'm going to split this angle into two. So I'm going to draw like a line that goes from here to here. Okay. And I'm going to call this angle on this side of the line X and this side of the line Y. Okay. So I'll split it up. Now, if we look at just this triangle now, okay, just that one. So ignore the left-hand side for a minute. You should realize that what you're looking at here is an isosceles triangle, because if that's the middle of the circle, then this line and this line must be the radius. They must be the same length. If that's an isosceles triangle, then this angle here must also be y, because they must be the same, because that's what an isosceles triangle, the two base angles are the same. And then this angle here, how would you normally work out what that angle is? If you knew the other two angles in the triangle, you'd do 180 minus the other two angles. Let's do it. That is 180 minus y, which is 2y. So that's what that angle is. Okay, that's what that angle in the middle to the right there. Let's now move to the other side and do something similar. So this angle here, I called x earlier, right? Let's put it in green to show the difference. Now, if we just look at this left-hand triangle now, the one in red, isn't that also an isosceles triangle? Because we have a line going from the middle of the circle to the edge of the circle, and then another line going from there. So this side and this side must be the same length. So it's another isosceles triangle. And if x is the bottom angle, then x is the other bottom angle as well. They are both x's. And in the same way, this angle here then, if I said work it out, you do 180 minus x, which is 180 minus 2x. Right. Then, finally, nearly there. This angle down here, which is the angle we care about, remember that's the angle that's twice as big as that angle at the top. How would you normally work out what that angle is? Well, you know that angles around a point add up to 360 degrees. This should add up to 360. So to work out this angle, wouldn't I normally do 360 minus the other two angles that are either side of it? And they are 180 minus 2x, you've got to use brackets here, and 180 minus 2y. That's what they are. Okay, so to work out the angle at the bottom, you do 360 minus the other two angles. Let's expand and simplify this. That is minus 180 plus 2x minus another 180 plus 2y. What's happened here? We've got 360 minus 180, which is 0. That's all gone. What are we left with? 2x plus 2y. So we have shown that this angle here is 2x plus 2y. And what was the angle at the top? It was x plus y, because it was those two, wasn't it, that we split in half earlier and called it x and y. So we have shown that if this angle is x and y, this angle is two lots of x and y. In other words, that the angle in the middle is twice as big as the angle at the top. That's what a proof is. And you have about 3 more of those to remember for 3 of the other circle theorems. So there's one for the 90-degree angle in a half a circle. There's one for the alternate segment theorem. I think there's one for the cyclic quadrilateral, I think. So for about 3 or 4 of the circle theorems, you have to do some proofs. I wouldn't worry about the proofs for now. Okay, it's a long way away if you'd worry about proofs. There's plenty of other things to worry about. It is quite a complicated topic, as can be proved by where you would find it on Maths Genie, just so you know. It is down here, right? That's where that is. So I think there's other things to focus on. Right, assuming there is nothing else that nobody has asked me, and I've gone through any homework questions, I shall, at this point, stop. And remember, you've got the WhatsApp number, so ahead of the Wednesdays, preferably on the Wednesday, if you do have any questions, then feel free to send them just before the meeting. If it's just before the meeting, it's easier, because then I don't lose them all. If you send it like on a Sunday, we won't find it. So if you just do it on the day, then it's easier. So feel free to do that. Otherwise, that's it. I'll let you go. See you when I see you.